presentation with an amazing scientist. We are going to start with Jake Karstens. Jake is a meteorologist and graduate research assistant at the Department of Earth, Ocean, and Atmospheric Science at Florida State University, who is going to talk to us about his research, and his presentation is called Hurricanes, a powerful link between the atmosphere and the hydrosphere. So without further ado, Jake, I'm going to turn things over to you.
All right, thanks a lot, Brian. And first of all, as I get my screen set up, I just wanted to acknowledge Brian and Stephanie for putting all of this together. This is really a great workshop that they've put quite a bit of effort into really putting together for everybody. And also thanks to all of you for participating in this and for letting the science geeks like me out there come into your classes and try to leave our impact. I know the work that you do is very, very important. And it's an honor to be able to collaborate with all of you more and more over the last few years or so. So without further ado, I'll jump into things. If you can't see my screen, somebody let me know, but I think it should be fine. But yeah, I think this is a well-timed talk given yesterday's events with Tropical Storm Elsa making landfall near Steinhatchee in the Big Bend. And as we're starting to kind of get into the thick of hurricane season, I figured it'd be a good time to kind of talk about some of the basics and also some of the work that I do at Florida State and ways that can kind of help out in terms of hurricane forecasting. So just a little bit of an intro about me. I'm a fourth-year grad student at FSU, so I'll be finishing up my PhD probably next summer. But I did my bachelor's and master's degrees here at Florida State as well in 2017 and 2019 respectively. And like all of you, my ultimate career goal after graduation is to teach. I've always been very passionate about that. And that's another reason why I love to do the scientist visits that I've been able to do over the last year or so. Ultimately, I want to stay in academia as a professor in atmospheric science, meteorology, so on and so forth. And again, my research deals with hurricane formation as well as the organization of tropical clouds and thunderstorms. So this little video that I'm going to play right here is basically one of my model simulations where all these random white spots are just clouds interspersed throughout my domain. And then as time goes on, these eventually self-organize and actually form hurricanes, which spin around and interact with each other. So it's a very aesthetically pleasing line of work. I don't do anything that's like a real world hurricane, but it's a way to basically study them in sort of their own bubble and see how they want to behave without any kind of influenced by the surrounding atmosphere. So here's my contact info, which I'll leave at the end of the presentation as well. And all about hurricanes here. We know, obviously, living in Florida, really any part of the state, we know them pretty well for the extreme winds and rainfall that they can bring to our state very often, as of course, a key example from a few years ago being Hurricane Michael, which hit the Florida Panhandle in 2018. But something that's perhaps unsung sometimes, given how much emphasis we place on the intensity, the maximum wind of hurricanes, is that these kinds of impacts oftentimes extend well away from their centers of circulation. And that's something that the Florida Peninsula really felt over the last couple of days, despite Elsa making landfall all the way over here, just about in Taylor County. We had pretty widespread rainfall and tornadoes that even stretched from Jacksonville down all the way to Miami. Hurricanes draw their fuel, both in terms of heat and moisture, from the ocean surface itself. So whenever we're talking about sea surface temperature, warmer water often favors stronger storms. And that's why our peak season really doesn't start to kick in until the summertime, when the Gulf of Mexico, the Caribbean Sea, the Atlantic Ocean temperatures are their warmest. And this heat is transported upwards through the atmosphere as we eventually get condensation into clouds, usually in the eye wall, where you have this really intense rainfall and strong wind. And really heats up the middle and upper atmosphere as well. So it's really a full atmospheric kind of system. How we analyze them, there's really several ways. And before we had satellites, we only were able to really measure hurricanes if they made impact on land or if we had a ship that unfortunately sailed right into its path, for example. But weather satellites really got going in the 1960s and has advanced substantially since then, taking pictures of hurricanes basically from space every few minutes. We're even able to infer a lot about the strength of a hurricane and its sort of integrity just by looking at how the clouds are structured on a satellite picture. And we've actually developed a scheme to estimate the actual intensity just based on this without actually taking a measurement of the wind, for example. And there's also instruments on board satellites which can directly measure the winds. It's not just taking pictures. You can get profiles of humidity and temperature and wind and everything like that. We've also developed a growing network of buoys in the oceans, which basically just float around and measure different oceanographic and meteorological variables like wave heights, ocean temperatures, winds, pressure, so on and so forth. So that can be a useful way to basically get some ground truth when we have an estimate of a hurricane's intensity from satellite, for example, and we just want to verify that and calibrate it. But we need a storm to pass nearby for that to really be the case. So arguably the most powerful tool that we have, at least in the Atlantic basin, is the Hurricane Hunter aircraft reconnaissance. The Hurricane Hunters from both the National Oceanic and Atmospheric Administration, NOAA, as well as the United States Air Force, fly into hurricanes with instruments on board the aircraft, including radar, barometers to measure pressure, anemometers to measure wind, speed and direction, so on and so forth. And these planes will also release instruments called dropsondes from the plane that descend down through the atmosphere. So it's almost like the reverse of the weather balloons that you might have seen if you've ever seen the National Weather Service office that's closest to where you're located. And these just descend through the atmosphere and collect measurements of humidity, pressure, wind, temperature that really inform us very well about the structure of a hurricane. And that data gets fed directly into the forecast models, which will forecast its future track intensity and interaction with its surrounding environment, basically. So very important information, high resolution data that really can help us to make the forecast as good as we can. My research specifically deals in model world. And as we've been able to have more computing power over the last 20 or 30 years, our ability to model the weather has really improved substantially. And that allows us to forecast hurricanes in real time. If you've ever tuned into a hurricane forecast, you might hear about the GFS versus the Euro. It's these very, very pronounced atmospheric models that we have from both the United States as well as the European Center for Medium Range Weather Forecasting that oftentimes compete against each other to get a hurricane forecast the best. But we can also perform any idealized kind of experiment that you can imagine, which is where my work really comes in. These models will basically solve these well-constrained theoretical equations for atmospheric motion, moisture, so on and so forth, given some set of initial conditions. So that could be a realistic scenario. You could take the weather that actually happened a few days ago and run a model and see if you can reproduce what eventually happened. Or you could do what I do, and basically in my work, I just randomly disperse clouds throughout some square. And this GIF that you see on the top left here, all these green areas indicate where you have higher humidity, so more moisture, while the brown is more dry areas. And you basically see everything kind of randomly scattered throughout this square until you get later on in the simulation, and all of a sudden you see this well-defined circular area of moisture coming together that eventually spins up into a hurricane with its well-defined eye right here by about day 70 or so. So it's a really interesting interaction between clouds and their surrounding environment that actually helps them to sort of self-organize. We don't have any kind of circulation that forces air to come together and these clouds to really start to cluster. It's kind of more under its own free will, which is, I think, pretty exciting and really allows us to kind of get to the very basics of how hurricanes form. And that's important because our forecasts of hurricane track and intensity have gotten a lot better over the last few decades, especially with regards to track. This is the basically forecast error at certain lead times from the National Hurricane Center, how that's evolved from 1970 to the present. And these downward trending lines mean that the error has gotten lower. Our forecasts have gotten better, especially at farther lead times from maybe 4 to 5 days or something like that. And that's improved quite a bit, as well as forecasts of intensity to a slightly lesser extent, but there still is plenty of room for us to improve, obviously. And any errors that we might have could mean big impacts in terms of things like storm surge and rainfall and and even structural damage from wind along the coasts. So my work is still working to understand the nitty-gritty physics of how hurricanes form down to their very basic levels, which hopefully is going to improve forecasts of their position, motion, and strength. Because if we can figure out the starting points, it's going to just help us to really figure out things down the road a lot better. And it's also going to help us more confidently assess how hurricanes might change in the long-term future. We've already seen some interesting trends over time and things like hurricane intensity, for example. And we want to be able to have a better idea of what's going to happen over the next century, for example. So why this matters? Clearly, hurricanes pose a significant risk to people and infrastructure. And this is an example from Hurricane Harvey in 2017, which is one of the more prominent examples over the last decade that contributed to a ton of flooding in the Houston area. And since hurricanes draw fuel from the oceans, the warmer waters that we've been seeing in the Atlantic, for example, over the past few decades, will likely increase the potential for hurricanes to strengthen and maybe reach major hurricane intensity like Harvey did on its final approach to Texas. And a warmer atmosphere can also hold more water vapor. Just think about your average day in South Florida in the summer, for example, compared to maybe, sometime in the winter months up north where it'll feel a lot less muggy outside. It's basically just like that. And if you're able to hold more water vapor, you're also able to have more rainfall potentially. So we're really looking for these two things in particular, as well as the increased potential for flooding from storm surge along the coasts due to the rising sea levels that we've also seen over the past couple of decades. So I'm almost done here, but some of the outreach that we do in our lab, my group led by my advisor, Dr. Allison Wing, and as well as a fellow grad student, Evan Jones, and we've teamed up with the CEFS program as well as FSU's Science on the Move to do a couple of visits over the past few months using the weather in a tank system that my advisor has set up over the last few years to demonstrate different concepts of atmospheric dynamics. So I'll play this little video that's kind of a teaser of some of the experiments that we run. We've created a playlist of videos that we recorded in our department's TV weather studio, which has been a lot of fun to build. And these are uploaded in a playlist on YouTube, which you're free to check out and share as much as you'd like. And excuse me. And this is going to be basically the backbone for the visits that we're planning to do over the next year. We're working to expand on the set of experiments that we have available and plan to do quite a bit over the 2021-22 academic year. So if you're interested in having us talk to your class, don't hesitate to reach out. We'd love to make the visit since we have a handful of us that are all kind of on the same page here. So there's a good chance you're going to have some kind of availability from us. So thanks a lot. Again, don't hesitate to reach out if you want to collaborate on any kind of weather-related outreach or just want to talk hurricanes a little bit. I know 2021's gotten off to a pretty hot start, but fingers crossed that things cool off a little bit and it's a little bit less wild than 2020 was. But here's my contact info one more time if you want to jot any of that down. And again, feel free to contact me if you ever want to talk hurricanes or have us come visit. Thanks a lot.
Jake, thank you so much. Really interesting presentation. Really appreciate you joining us today. We do have our Q&A scheduled for 10 o'clock if you are willing to stay around and answer some questions then. Alternatively, if you're unavailable, there are some questions in the chat. If you just want to answer directly, that would be great too.
Okay. Yeah, I can stick around, but I'll respond to the ones in the chat throughout. So yeah.
Great. Thank you so much. Thanks again. We're going to move on to our next speaker. Our next speaker today is going to be Dr. Yilin Zhang. She is a Water Resource Regional Specialized Agent with the University of Florida's Mid-Florida Research and Education Center, or UF-IFAS Extension Central District. And she is going to talk to us about her work for a presentation called Dive into Water Curricula. So Yilin, I'm going to turn things over to you.
Thank you, Brian, and thank you for inviting me to present at today's workshop. I don't know if it's intentionally to schedule me right after, like schedule a gator right after a seminal. I think it's intentional, but we will keep it light. All right. As any educator, it's when you ask to do a talk for hours, you're like, at least me, it's like, I got it. But today I was told I only have 15 minutes. So without too much introduction, let's just dive into the water curriculum. So like Brian introduced, confused, I'm affiliated with extension. So just wondering, have you heard of extension? If you heard of extension, have you used the extension or collaborated with extension? So for those who may say no, then just a quick introduction. What is extension? I always say the best way to describe us, like extension, is we're the extension of University of Florida. We provide science-based and university-based knowledge to the public. So here you can see all the topics covered under extension. Basically, it basically is everything you can find under the sun. So from agriculture to natural resources, food safety, financial management, lawn care and gardening, 4-H youth development, sustainable living, and family issues. So we deliver these science-based knowledge to public in different formats. Traditionally, we have in-person workshops. During the COVID time, we switch a lot to online, like webinars. We also have one-on-one consultations, demonstration, field days, and more through the local extension office. So you can see the map on your right. We basically have at least one extension office in every county in Florida. And here you can find our link website. Just a little bit about me. My name is Yiling Zhuang. I usually just go by my first name because I don't think you can find a second Yiling in University of Florida. Much easier to remember and still a little bit hard to remember my name. So if you're a beer drinker, then just associate my name with the Pennsylvania beer, Yiling. So it will be close enough. So I will respond no matter which way you call me. And my official title is the Water Resources Regional Specialized Agent. So what brought me to that position, it's like my education background. I'm a civil and environmental engineer by training. I'm also a lead accredited professional with the building design and the construction specialty. And recently, I obtained FAA certified remote pilot license to operate small UAVs. So it's another fancy way to see drones because we see the application of drones in so many fields. That's the latest, another like my extension efforts is how to utilize UAVs in water resources management. So from what I've just said, you can tell my work is a lot about water. So because it's just my title, I'm the Water Resources Regional Specialized Agent. So what I want to start today's talk, it's just want to get a feel what you think when you hear the phrase Florida water. So what other words or phrases came to your mind? I already saw an answer posted in the chat box. So I like to keep it a little bit interactive. So hold on to your answers. I will post the link again because we will use this third-party software called Pool Everywhere. So once you click that link, you can put your answer in, and then we'll see the word cloud. So if you don't see the link, I will post it here again. So all you need to do is just click that link and it will direct you to another web page. And I keep it anonymous, so don't worry, I won't track down who put what. And if you put 2 words there, just use underscore. So for example, if you put Hurricane Elsa, so if you put 2 words separately, so they will recognize the 2 words. But if you put Hurricane underscore Elsa, then it will consider 1 word. Awesome, I already see a lot of answers popping. And I see springs. This word is the center. And it keep moving, but still springs is it's in the center. In other words, I see here it's a lakes. It moved again, river, brackish. Awesome. So I'll give you 5 seconds if you haven't put your answer in. You can put more than 1 word. All right, I will just stop here. So from this, you can tell Florida has a lot of water resources. Just based on the answers we have here, we have springs, so we have ocean, because Florida's 3 sides surrounded by water. So without getting into too much detail into Florida's water, I would like to ask you another question here. It's, do you think we have enough water? So it's still the same link. So most of you here put no. It's more like 2/3 said yes, 2/5 said yes, and 3/5 said no. And I see some comments, it's like, it's a tricky question. It is, right? So without really answer your question, I would like to move on, just to show you some data, and then probably we can go back to revisit the answer. So this is the Florida's population future. This is a research conducted by 1,000 Friends of Florida. So you can see the baseline here is a population in 2010 with 18 million population, and it is projected by 2070, the population will reach almost double to 34 million. And the red areas mean it's developed areas. So from the map, you can see most developed areas in the future will along I-75, and more it's like inland. Coastal areas will still be very developed, but it's also moving into inland areas. Then what does that mean to Florida's water? So population change means water withdrawal change. And this is the population change and water withdrawal change between 1950 to 2010. So in these 60 years, population and water withdrawal almost increased by 6 to 5-fold. So what does that mean to Florida's water future? That's the same study conducted by 1,000 Friends of Florida. So you can see here, it's the redder the areas are, means the high water demand per acre. Per acre per day. So the pattern basically mirrored Florida's population change. You will see a lot more red areas along the coastal areas and also inland Central Florida along I-75. So what does that mean? It's in Florida's water demand. So that's between 2015 and 2035, the total water demand is estimated to increase by 1.2 billion gallons per day. It's 1.2 billion gallons per day. And if you look at this diagram, public water supply and agricultural water will remain the high water users. And if you look at one example, this is Eagle Lake in Central Florida. And based on their water demand, in 2017, the water demand has already exceeded the permitted water supply. So in other words, they do not have enough water to meet the water demand without causing any negative environmental impact. And this pattern, it's not unique. To be honest, it's quite common throughout the state of Florida. The next example I would like to show you is the Central Florida Water Initiative. So this is a regional water supply plan. It covers 5 counties. So Southern Lake, Orange, Seminole, Osceola, and I forgot the other one, kind of escaped. It's Seminole, Osceola, and I think oh my goodness, it kind of escaped me, but it's the central, it's the Polk County, excuse me. Let me rephrase. Central Florida Water Initiative covers 5 counties, Southern Lake County, and also Orange, Osceola, Seminole and Polk counties, all the counties. It covers about 5,300 square miles. So you can see it's a really big area. And this is their 2020 regional water supply plan. I highlighted in red in the bottom. So traditional resources alone cannot meet future water demand or current permitted allocation without resulting in unacceptable impact to water resources and related natural systems. I really like this diagram. It's because you can see, based on the groundwater assessment study, available groundwater is only 760 million gallons per day. And the projected water demand in 2040, groundwater demand is 855 gallons. So which is already exceed the yellow line. And once it go beyond the yellow line, then it will trigger the minimum flows in the levels of the springs. It will also stress wetlands. So that's why it's when the water demand cannot meet the current available water, then alternative water resources need to be identified, and also water conservation strategies need to be identified. So at this point, I'm not going to ask you that question, but you can ask yourself, do you still think we have enough water? So you may not notice why I gave that short presentation. Actually, that's a sample of Florida water stewardship. So I always think the learning by, I like the model learning by doing. So what you may not notice, you just experienced a teaser of extension program. So this the sample I just presented is part of the program called Florida Water Stewardship Programs. And the topics include water quality, water quantity, water supply, water policies, and also emergency water issues. Like recently on news, we hear a lot, it's pharmaceuticals, plastics, microplastics, and PFAS, so which is fire retardant materials. We find it in soil, and we also find a very low concentration in some water bodies. So this program also covers these emergency water issues. I have conducted this a program to, or you probably not the whole series, because the whole series contain like 10 topics. So I just pick and choose. I did it to K-12 educators, gave them an overview of Florida's water resources and the challenges facing Florida's water. And also did a similar, tweaked it a little, and did that program to policymakers and decision makers, and also to general public. So just want to let you know, because if you haven't experienced extension, I think that's the best way for you to understand what extension program is. So it's just a little bit about my extension programs. So as my title, I'm the water resources regional specialized agent for Central District. And I'm housed in Mid-Florida Research and Education Center, which is in Apopka. So from this map, you can see Central District covers 11 counties. That doesn't mean it's like I can only outreach in 11 counties. It's just my data, all the research, it's more focused on Central Florida. If you would like some general Florida talk, like the one I just introduced, the Florida Water Stewardship Program, I will happy to work with you and see how we can have that program in your school. I list some, it's just my major extension programs. It's drinking and residential water. That includes water sampling. You get samples and you test if it have bacteria, it have lead, these drinking water issues. And also wastewater management, including like septic systems or even storm waters. And water for agriculture. So that's the reason, that's my recent extension program, is how to utilize drone to, one big application of drones is in agriculture and the natural resources. So that's one of my extension program. It's just to fly the drones and get some image data and analyze the data, see how we can better manage water resources and precision agriculture. Also watershed protection and restoration. And the last is environmental literacy for K-12 educators and the students. One thing I forgot to mention here is for emergency water issues, I do have equipment to sample microplastics. That's a program developed, created by, now it's the Sea Grant program leader, Dr. Maya McGrath. We created a very simple protocols for middle school and high school students to collect samples and then to filter and count it how much microplastic we can find in our water bodies. And with that, if you are interested, here's my contact info. You can see it's the digital time. It's all my digital, it's all my digital contact, from my email to Facebook to Twitter, blogs, and YouTube. So that's all the social media accounts I can manage. So I don't really have Snapchat, because I know for students now, they use Snapchat a lot and TikTok. I really don't have time to expand my social media management. So here are all the contact info. You can find me. I will be happy to provide any outreach program in your school and with your students. And with that, thank you for your time and looking forward to any comments. I'll probably will be later.
Thank you so much, Elin. I can appreciate the non-expansion of social media. I too do not have TikTok or Instagram. So great presentation. We really appreciate your time. Are you able to stay on for a few minutes? We've got one more presenter and we'd love to have a Q&A afterwards if you are. If not, as Brian mentioned earlier, we're happy also for you to reply to any questions that might appear in the chat box for you. Either way would be fine with us.
Yeah, I will stick around.
Awesome, fantastic. Well, our next presenter here is Dr. Wendy Graham. She is a Swisher Eminent Scholar, a hydrologist, and the director of the University of Florida's Water Institute, which is one of our amazing sponsors for this PD. I'm going to turn things over to her now. It looks like she's pulling up her presentation and we'll let her get right started away here. Thank you.
Okay, did I click all the right buttons? Is the right presentation up?
It sure looks like it to me. I think so.
Okay, great. Well, thank you. I appreciate the invitation to talk to your scientist in every Florida school, especially on the hydrosphere. My name is Wendy Graham. I'm a hydrologist and a water resources engineer. I'm director of the University of Florida Water Institute and the Carl Swisher Scholar in Water Resources. What I want to talk to you today about is the University of Florida Water Institute. We are formed, we're a cross-campus entity celebrating our 15th anniversary this year. And basically we were formed from a grassroots faculty effort that recognized that our water challenges required us to be looking at them from multiple perspectives, not a single discipline, not a geologist, a hydrologist, an engineer, an agronomist. So our mission is to bring together talent from throughout the university to address these complex water issues through interdisciplinary research, education, and outreach programs. And currently there's 307 University of Florida faculty members who are affiliated with the Water Institute from more than 65 different departments and centers. So you can see from just the distribution of all the water expertise on campus, you know, our job is a big one to try to pull people together. I know you've been talking about water all week and we'll continue to talk about water, but some of the major water issues that we're experiencing, not just in Florida, but in the nation and globally, we've historically tried to solve these problems with purely engineering solutions, but we now realize we need creative transdisciplinary solutions that take a look at people's behavior and policies and economic incentives, as well as the science and the engineering. So some of the major water issues that we address are increasing water demand. As we saw from the last presentation, we have a growing population, We have increasing urbanization and high per capita consumption that are putting constraints on this fixed water resource. I saw there's sort of different opinions on whether there's enough or not enough, and it really does depend on how we use the water, how careful we are with what we put into the water while we use it, and how we price water for people to use it more efficiently. In addition to increasing demand, there are issues with access to clean water and sanitation, and this is not just in developing countries. Increasingly, there's a focus on environmental justice issues in the United States. A couple of examples of areas where access to clean water and sanitation is not universally available is the Flint, Michigan crisis, where lead in the water supply was a big problem, and it was not uniformly distributed, but more of an impact on the poor and underserved communities. Migrant communities near the Mexican border, Native American communities all have issues with access to clean water and sanitation. Another issue we deal a lot about, and I'm sure you've heard a lot about, is the water quality and ecosystem impacts of human behavior. And this can produce both human health problems and ecological health problems. Pile on top of that, the climate variability we see. We just went through Hurricane Elsa. We have routine floods and droughts that come on an interannual and multi-decadal basis from a natural system, and this is compounded by impacts of climate change and sea level rise that have been increasingly recognized and dealt with. I'll talk a little bit more about that later. And add on to all these issues that we are dealing with is issues with the public's willingness to change their behavior, willingness to pay for solutions to these problems. So there are no shortage of issues for faculty within the Water Institute to deal with. And some of the programs we've developed to address these issues are sort of primarily interdisciplinary research projects, and I'll give you a few examples of these in a moment, but these are areas where we build teams of faculty across UF and with other universities to address these complex problems. We also have a program where we develop scientist stakeholder partnerships to build communities of practice, enhance networking, work on co-production of knowledge with users, and foster applied research. We provide peer review services and expert assistance to state agencies that are tackling these difficult water issues. We have an interdisciplinary graduate fellows program I'll talk to you a bit about later, and also a Water Institute symposium that we host every 2 years to bring together academics and agency people and stakeholders and the public throughout the state of Florida to talk about these water issues. So a few examples of our interdisciplinary research projects. We have a large 5-year grant funded by the U.S. Department of Agriculture looking at the sustainability issues associated with the Florida aquifer, which underlies the entire state of Florida and parts of Georgia, South Carolina, and Alabama. And basically what we're looking at in this project is we're trying to understand what changes are needed to maintain a robust agricultural and silvicultural economy while protecting the water quality and the water quantity of the Florida aquifer and the springs and rivers it feeds. I noticed in the word cloud a little bit ago, there were springs showed up quite predominantly, rivers, lakes. It's really the Florida aquifer, the groundwater system, that is feeding most of these in Florida, at least from the north border with Georgia all the way down to just about Lake Okeechobee. So this aquifer provides water to more than 10 million people and feeds irrigation for agriculture that was also discussed in the last talk. So what we're doing is working with stakeholders to develop models to predict outcomes of alternative scenarios, as well as incentive programs and educational programs for improved decision-making. And kind of the big idea behind this project is we need to understand the changes we need to make in order to achieve the rather stringent environmental regulations we have set for ourselves in Florida, the minimum flows and levels in our aquifers and springs and rivers you heard a little bit about before, as well as the numeric nutrient criteria we've set for springs, which is a 0.35 milligrams per liter nitrate, which is quite low. So the idea is that we should think about developing a payment for ecosystem services framework that incentivizes agricultural and silvicultural producers to really maximize their land's potential for aquifer recharge, aquifer water quality protection, carbon sequestration, and wildlife habitat, in addition to the food security and rural prosperity that those lands also provide. And these agricultural and silvicultural producers are generally competing in global markets, which dictate the revenue they receive from their crops or forest products. But they're also providing everyone with essential ecosystem services that they're generally not compensated for. And there may be changes to their cropping systems and water and nutrient management practices, cover cropping or buffer systems that might reduce their product-based revenue, but provide those essential and irreplaceable ecosystem services that we all benefit from and no one else can provide for us. So this is a project that we are working on with people from faculty from the University of Georgia, Albany State University, Auburn University, and within the state, working with Florida Department of Environmental Protection, Department of Agriculture, Swanee River Water Management District, the NGOs you see down there. So it's a very large, complex project that we're right in the midst of right now. Another example of a research project that is focused on water for humans, the last one was focused on reconciling water for agriculture with the economy and water for springs ecosystems. This one, we're focused on using NASA Earth systems data together with climate models and hydrologic models to help actively improve the water management decisions that our public water supply utilities and water management district makes. So this one, we are working with Florida State University. I tuned in just as we were hearing from people from Florida State University. They're the ones that have developed the climate models. We are using the hydrologic models and working with Tampa Bay Water and Peace River, Minnesota Water Authority to produce real-time seasonal forecasts of rainfall and temperature to help improve their water storage allocation and supply decisions. And a third example, just to sort of round it out, this is a project that focuses on water for coastal fisheries. This is a project looking at the entire Swanee River Basin and looking to see how changes in land use and changes in climate will affect the freshwater flows into the estuary and the nutrients discharged into the estuary and the impacts of those changes on the fisheries in the Gulf. So we're partnering here with the Nature Coast Biological Station in Cedar Key, as well as the Swanee National Wildlife Refuge, Florida Fish and Wildlife Commission, the Swanee River Water Management District, Florida Department of Environmental Protection, and DACS. So these are just a few examples, water for agriculture, water for forests, water for fisheries, and water for humans, where we're looking at climate and land use and economics to try to do a better job of understanding the trade-offs and making appropriate decisions. I mentioned that we also have programs looking at scientist stakeholder partnerships. One of our oldest one of these is the Florida Water and Climate Alliance. For details, I have the URL right there, floridawca.org. This has been going on for 10 years. We have about more than 620 stakeholders, 25 workshops we've held over that time period. And basically, the goal of this group is to increase the relevance of climate and sea level models for Florida, specifically to improve our understanding and use of water in the state. So this was founded out of some frustration on the part of academics and utilities and water managers that a lot of the climate change community were really focused on impacts of snow melt in the Western United States. And our problems in Florida are a lot different than that. We have sea level rise issues, changes in climate patterns. Most of the climate models consistently predict increases in temperature, but there's lots of uncertainty in what will happen to rainfall. So what this group is doing is sort of downscaling those models for Florida and looking at ways to reduce risk and increase the resilience of our water supply. And as an aside to that, thinking about how climate change and how sea level rise might affect the minimum flows and levels and the numeric nutrient criteria regulations that we're working so hard to achieve. I mentioned also we provide water peer review and water expert assistance to state agencies. This is kind of a listing of things we've done over the last 8 or 10 years. We advise Florida agencies and the legislature on science-based knowledge that could impact decisions about minimum flows and levels that we've talked about, total maximum daily loads that are intended to protect our springs, rivers, and lakes. We've provided expert assistance on Everglades restoration, Lake Okeechobee operations, which are big in the news now, springs protection, coastal system protection, and development of alternative water supplies. One of the most recent panels that I've participated on is the City of Tampa asked for a scientific review panel to look at their proposals for indirect potable reuse of treated wastewater. So again, back to that question earlier, do we have enough water? I think the question is, do we have enough water of the right quality in the right place, leaving enough in the natural ecosystem to protect the ecosystems we value? And one of the things that we have relied on for a long time is this sort of one and done, use water, flush it down the toilet, get it to the wastewater treatment plant and pump it out or let it drain out to the ocean without reuse. So lots of cities in California and Texas have actively built both direct potable reuse and indirect potable reuse, where wastewater is treated and either put back in the aquifer for withdrawal for water supply, or maybe even piped directly to the intake of the water treatment plant. So in Florida, we don't do the direct potable reuse yet, but City of Tampa is looking at some indirect potable reuse, which requires more stringent water quality monitoring, treatment and monitoring. Anyway, that's an idea of sort of advancing the one water concept, where we need to holistically manage our groundwater, surface water, drinking water, stormwater, wastewater. It's all one, and we need to manage it together. So thinking about graduate education programs, we have developed what we call the Water Institute Graduate Fellows Program, which sort of changes the way PhD students are trained in their academic programs. You know, traditionally, you're in a department, you have an advisor and a very deep dive into a particular discipline. The Water Institute Graduate Fellows Program is designed to pull together faculty graduate student teams from 5 or 6 different disciplines to conduct research on some emerging water issues, and looking at the social science, the natural science, the engineering, and the legal aspects of those problems. So we've had 6 cohorts so far. The first 2 cohorts were focused on Florida's numeric nutrient criteria. As I mentioned before, our nutrient criteria for Everglades and for springs and for our estuaries are quite stringent and difficult to achieve unless we change the way we do things. We had a cohort looking at sea level rise. More recent cohorts have looked at water issues in Brazil and Costa Rica and Greenland. And the very most recent one that we're kicking off is looking at this one water concept and overcoming barriers and identifying opportunities to reuse treated wastewater, in particular for Florida agricultural production. And finally, We have a biennial Water Institute Symposium. The next one, COVID willing, is coming up in person for February 2022. We squeaked our last one in February 2020, just before COVID shut down our whole society. But this may be something that you would be interested in attending. We have worked with the TESI to bring teachers and bring academic programs into this. And as I mentioned, it'll happen in Gainesville, February 22nd, 23rd. We bring people from all over the state, consultants, government agencies, water management districts, non-governmental organizations, public citizens, teachers, stakeholders to talk about the major issues facing our region. So in summary, and I hope that we have plenty of time for questions, what the Water Institute does is basically build partnerships among diverse stakeholders, scientists, to figure out what our problems are, understand the problems, and work to provide engineering, legal, educational, and economic solutions to these water resource issues. We serve as a go-to place for peer review and expert assistance for Florida agencies. Through our graduate education program, we work to prepare scientists, engineers, planners, communicators, and policymakers that are trained to talk across their disciplinary boundaries. We convene meetings to discuss and talk about water issues, and all with the idea of ensuring sustainable water resources for Florida, the US, and beyond. So I'd be happy to stick around for any questions. Our website is there, waterinstitute.ufl.edu. And you can browse through the 300 faculty and the projects that we have going on and the projects that we've completed. And any questions I can answer, I'd be happy.
Thank you, Wendy. We really appreciate you joining us this morning. We actually do have quite a few questions. So just to jump right into it, our first question is from Sonia, who asks, are there any evidence that plastic waste, whether micro or nanoplastics, negatively impact the Floridian aquifer system?
I would say that the places that we, not meaning me personally, but faculty associated with the Water Institute have been looking are mostly in coastal and surface water systems. For plastics to get into the Floridan aquifer, they would have to infiltrate through the soil. I mean, there would be sinkholes that could get direct flow to as well, but in general, most of the recharge happens through the soil system that would probably have a better job at filtering the plastics out. I would guess if we look, we'll find it, but the people that are working hard on this right now are focused more on surface water systems, to my knowledge. And I invite anybody else out there that knows of someone focused on the Floridan aquifer to jump in.
May I just add a few just to that? Because I work with Dr. Maya, just like Wendy just said, yes, it's most study focus on coastal area, but I was sampling Florida Springs with some high school and middle school students and also intern. So we collect samples. It's at the spring boil, Silver Spring and the Rainbow Spring boil. Not enough data. We collect 50 samples. It sounds a lot, but still it's not a lot to show any solid evidence. But yes, we did find microplastics. Some is like 30 feet below the surface.
Thank you. Thank you both. Yilin, our next question is actually for you, and then we're going to come right back to Wendy. Chris is asking, where would be a good starting point for developing units, lesson plans involving the use of drones with high school students?
That's a really great question. We just, I was not involved in that summer camp. A few colleagues, 4-H agents, they did a summer camp for high school students, particularly like how to use drones. And they started first, it's like how to become like all the regulations and ins out to use drones. So more like how to prepare for the FAA certified license, FAA certified like remote pilot license, how to pass that exam, and what's the legal point to use that. Quite surprising. It's just quite different when we use a toy drone and if you want to use it for any commercial application. So that's what they did. And some other I'm not sure if we can call it a lesson plan, but we are planning to do drones. It's really just the applications, let the kids know what we can use drones for, because we know it using agriculture and the natural resources in survey. Even recent news, it's the building collapse in Miami. They also use drones to detect the rescue effort. So let them know the wide application of drones will be the starting point. And high school kids, we don't usually do a lot of depth, like how to analyze data. I will be happy to discuss with you a little bit more, see like how to fit your class better.
Thank you.
Thank you very much.
Dr. Graham, our next question is from Stephanie, who asks, how effective are all these programs if the populace does not buy into different water use?
Ineffective. I think that right now we all believe we deserve clean water, cheap local food, green lawns, and low taxes. And we're basically at that point where all of that stuff doesn't fit together. And I think we have to change the whole culture around the value of water and how we use water and how we reuse water. I mean, if we really thought that everything we do to that water is going to come back to us by a pretty rapid reuse through our system, we may be more protective. So I think we need to price water differently, and we need to change the culture around water use significantly. We need to pay for the ecosystem services to preserve them, because if the agriculture converts to urban and suburban, it's not a good outcome. We really need that open space as recharge areas, and it's going to require major changes, in my opinion. Yeah.
Thank you. Natalia, I see you have your hand up. Would you like to unmute?
Sure. Thank you for great presentation. Probably it will be a question or comment to Dr. Graham. What I want to say that in Broward County, we have this events, yearly events before Corona, when it was for education for public. So family event, people come in with kids, and they educate us about water, about earth, and how much we use water, how to decrease usage of water. So maybe we have to expand that in that degree that public will be educated about water usage.
I certainly agree with that. And I think the extension service that Yingling talked about is well positioned. There's an office in every county, and we have 5 regional water extension agents. In the past, the water management districts have had very robust public education programs. That's another resource. But certainly this is something that we really need to educate everybody, where their water comes from, where it goes after it leaves their home, where the water comes from that's feeding the springs, where the water comes from that's feeding our estuaries, and just to sort of reinforce that hydrologic cycle that maybe they got in 3rd grade and haven't seen since. But I agree, public education and education of decision makers is really a high priority.
Great. Our next question. Are there any efforts to remove pharmaceuticals from our wastewater? And what types of risk may that pose to the biosphere?
Is that for me?
Whoever wants to take it.
Yeah, I would say in the cities and states that are more aggressively pursuing indirect and direct potable reuse, they are looking at ways to take the pharmaceuticals out of the wastewater. They typically require membrane technologies at this point, and this is not my expertise, but and those are very high energy systems. So I think there are membranes that can remove these, and people are working on trying to improve that technology. So, but it's very costly and intensive. So it's an issue that all the pharmaceuticals that we use, most of them make it through the standard wastewater treatment process.
Thank you. Elin, is there anything you'd like to add?
I shared one, not particular to that comment, because I think Dr. Graham covered that. It's a membrane, it's very commonly used, but it's a very energy intensive. And so far the concentration of pharmaceuticals, it's quite low, hard to detect, and which also make it harder to remove it. That also go back, it's a similar, it's an emergency water issue like PPCP and also plastics. I saw a lot of people asking like plastic questions in the chat box. So I put a link, Dr. Maya McGrath's initiative, which is for the Microplastic Awareness Project. It has those slides, because I see some comments asking some more additional information. You can download those canned presentations and use it in your class.
Thank you. Our next question is about the springs. So people are wondering, how is it water impacted in terms of the quality of it when so many Florida residents and tourists are going swimming in it? And also wondering, is it safe to drink that water? And how are we as people interacting with the springs impacting it?
I mean, there's many ways we're impacting the sort of, if we start at the beginning, all of the activities we do with water in the landscape impacts the water that recharges the aquifer, the amount of it, and the quality of it. So in the projects where we're focused on springs, we're focused in the Swanee Basin, where agriculture is the major driver of nitrates in springs. But in other regions like Silver Springs and Rainbow Springs, septic tanks might be more important. But anyway, so we are impacting it by reducing the volume of water that emits from springs and increasing the concentrations of nutrients and whatever other chemicals we're using when we extract that water. That's one way. And then recreation itself has an impact on the springs ecosystem. So over recreation can disrupt the grasses along the spring bottom and cause changes to the ecosystem. So I think several of the parks have started to sort of limit the numbers of people that can tube and recreate on the springs at any particular time and by season. That's one way. And it's certainly safe to swim in. I would not drink the water directly. I wouldn't drink any water directly that hadn't moved through a water treatment plant or a home treatment system, put it that way.
Great. Does anyone have any other questions at this moment while we still have our scientists with us, our experts with us? Marty, I see you just wrote in a question. Would you like to unmute and ask that?
Sure. I'm not sure who this goes to, but being from Connecticut, I live in Orange County for the last 3 years. I noticed there's a lot of HOAs around here, and I was just wondering, is that a normal thing for most of Florida to have HOAs or gated communities, which of course we kind of require the green lawns, the manicured lawns, and things like that?
I'm not sure about statistics and how many and what percentage, but I know it's also been an issue in the legislature whether HOAs should be allowed to require a certain amount of irrigation or fertilization. If you look at the water use for public water supply in Florida, roughly 50% is used for outdoor use. So that to me is very low hanging fruit to both reduce the amount of water we use and reduce the nutrients that are getting into our water supplies. That's a personal opinion based on a water budget, but I think that the issue of using very much manicured lawn landscape versus Florida friendly landscape is something that we need to think about. Yinling?
Yes, it's because it's very common to be honest. I also live in an HOA, and HOA sometimes can be, I don't know, very strict. But reason, if you are familiar with Florida-friendly landscaping, so if you're like any homeowner want to adopt Florida-friendly landscaping, which the goal is just to choose the right plants, right place, and to conserve water and protect water resources. No HOA can, it's in the legislation, so no HOA can go against the Florida-friendly landscaping. So if you want to do that, you sure can do that. And I read one reason I was just informed last week, because even in HOA, you want to do front yard food, like food gardening. It used to be like HOA can say no to that. Now it's, I think the new regulation banned HOA to ban from front yard food gardens. But HOA may still have certain like criteria, but you can also do food gardening, because just like Dr. Graham said, irrigation uses a lot of water, at least 50%, and some neighborhood it shows like 75% just used in auto irrigation. And I think our horticulture agents like to say it's used on grass we cannot eat. So why don't we put water into good use? So I guess that's also why the new legislation allow front yard food system.
All right, I'm just looking back to the chat, see if there are any other questions that I missed. I think we'll wrap up with this last question. Last question during this session is going to be from Stephanie, who asks, when land use expands, animal populations contract. How does this impact water quality? Is this something that is typically considered?
Well, depending on the type of land use, urbanization is what is happening most often. Certainly the changes in the water balance and water quality are taken into account versus natural systems. That effect on the natural biota, the animals and the wildlife, I'm not sure about that. I'm not sure. I don't know if Yinling knows. The minimum flows and levels are intended to protect aquatic wildlife, manatees, that kind of thing. They're certainly intended to protect wetlands, but more terrestrial animals and wildlife corridors, I don't know about that.
I only know a minimum because I just finished my natural resources leadership institution program. It took us to the corridor, Florida corridor, OTO corridor. So that's who are working, different agencies are working on that just to preserve for wildlife habitat. So I think it's Audubon, it's one of it. I cannot remember other agencies. They are trying different ways to build an corridor. When it's in Central Florida, because I-4 really block it. Another, it's Osceola to Ocala Forest corridor.
Mm-hmm. So I certainly think maintaining natural spaces for wildlife corridors, it will be beneficial to the hydrologic system and our water quality. I'm not sure of the vice versa. Of course, they also want good quality and water and that kind of thing. But yeah, the natural, maintaining those wildlife corridors has lots of ecosystem benefits, and providing recharge areas and filtration areas for water is one of them, in addition to the wildlife habitat.
Thank you. And one more just came in, so I'm just going to quickly ask a little bit of a, I guess, a personal question here. And this is, what type of water do you prefer to drink?
I prefer to drink the water that comes out of my tap. I don't like to buy bottled water. And I live in Gainesville. I like Gainesville's water.
Fine, that's great. Thank you. Keelan, any thoughts?
I have utility water. That's also, I like my tap water. If I can put a plug here, I have a program. It's for private well sampling. So if you are relying on private well for your home consumption, I highly encourage you to test the bacteria at least once a year. And if you could also test the nitrate and the lead, just these are very common contaminants inside the household for private wells.
Perfect. Well, thank you both so much for joining us, for amazing presentations and sharing your expertise. I know we really appreciate it, and we've certainly learned a lot. Teachers, this is going to take us to our bathroom break of the day. Before we jump into it, we once again just want to thank all of our sponsors who have supported this workshop in some capacity, whether financial or another, adding capacity to what we could do with this and helping to create this really excellent professional develop experience for you. That said, we are going to take our break. Like I said, please make sure that you come back about 10:30, ready to continue. And just like last time, you can turn off your camera, obviously, to go to the restroom, whatever you need to do. As soon as I see all of those cameras back on, I'll know you're ready, you're engaged, and we're ready to keep going. So thank you for a really great morning, and we will see you shortly.
All right, welcome back, everybody. It looks like people's cameras are starting to pop on here. Excellent. I'll just give it another few seconds here, and I will introduce to you our next guest and a little exciting event for you. Right. So next up, we're going to take a little virtual tour of the University of Florida's Tropical Aquaculture Laboratory with Dr. Roy Yanong. He's a professor and extension veterinarian with UF's IFAS Extension Division. He specializes in fish health and management and aquatic animal health, working closely with state and federal agriculture, as well as natural resource agencies, veterinarians around the state, and other fish health professionals. So Roy, the floor is yours. I'm going to let you take it from here. You are currently on mute, Roy. I don't know if you're talking or not.
Okay, can you hear me?
Sure can, yes.
Yeah, sorry, I was trying to flip the camera and it I may just have to hold it up and turn it around. So hi, everybody. I'm excited that you're able to join today. I am Roy Yanong. I'm an extension veterinarian and professor in the School of Forest, Fisheries, and Geomatic Sciences based at the Tropical Aquaculture Lab in Ruskin, which is a little bit south of Tampa. Today, I'm hoping to kind of give you guys a little feel for what we do in the diagnostic lab, talk a little bit about research, and maybe walk around to one of the buildings at least next door to kind of give you a feel for one of our research buildings. So with that said, I think the first thing I wanted to do was show you, essentially I work with the fish farmers, and a lot of our work is looking at fish health management, disease diagnostics. We look at water quality. When we're working up fish, we'll do a lot of external type biopsies to look for parasites and to look for normal structures. And then we also do cultures, bacterial cultures, when we will actually sacrifice the fish. Today, I wanted to do at least a live demo to show you, and I've got one of our students here. This is Pamela Betancourt. She is a fourth-year veterinary student who's interested in aquatics. So she's rotating with us for 4 weeks. And Pamela's gonna just do a real quick biopsy on a koi to show you what that looks like. So go ahead, Pamela.
All right.
So what she's going to do is basically take this koi out of this bucket and then put it into, we've got an anesthetic bath. We use a sedative called tricaine methane sulfonate, which will basically knock the fish out really fast. So here's a little, there it is. So you should see the fish start to turn upside down, hopefully in a minute or two. So yeah, so now I think he's getting upside down, getting close. And this is just so the fish is a little bit easier to handle. This fish, we're not going to actually sacrifice. We're just going to do some externals to look for parasites on it. So she's going to go ahead and grab the fish shortly, and then she's going to take samples of its fin, gills, and skin. You ready? All right.
All right.
So this is something, again, that we do really commonly. So she's doing a little bit of a scrape.
Do that one first.
Actually, if you can move your hand around.
See-
There.
Okay,
Yeah, go ahead. Go ahead.
perfect. And then now I'm gonna grab some of his fins. So I'm just gonna clip the very, very end as a sample and then place him on the slide. And then the last thing will be the gill. I'll very gently try to lift the operculum and grab just the edges. And there's plenty of gill right there. You see the sample?
Just go ahead and put it on
Oh,
there.
okay. I'm gonna put our fin back. We're done with him. Oh, man. There we are.
You guys can see that little red piece. All right, so we're going to show you kind of what she's looking for on the microscope. So just go to the gill. That's fine. We've kind of got this little screen here hooked up to our microscope. And she's actually putting the fish back in. It'll be fine. Just move the air stone in there. Yeah, and I'll okay. Make sure it's dry.
Roy, some
Yeah,
of us
I've-
are wondering how long can the fish stay out of water and still live?
Yeah, that's a great question. A lot of times, like if we are, and I've done surgery, a lot of my colleagues have, if you keep the fish moist, and we usually use a device that will keep water running over the gills, kind of like a ventilator type, we can, probably 45 minutes, an hour. Again, a lot of it is making sure you're ventilating the fish so it gets oxygen and keeping its skin moist. Those are pretty critical. So I don't know if you guys can see on the screen, these are pieces of gill. And essentially what Pamela is doing now is kind of looking to see if they look normal, if there's any parasites on them. And for me right now, they look fairly normal, but this is kind of part of our normal routine when we're working up a fish. Again, this is sort of just the very beginning of it. We're not going to do a whole kind of procedure with you with our necropsy because that would take too long. But just wanted to kind of get you all a feel for that. So she'll kind of go through all the different tissues. Just a little bit of a closer view of the gills. And yeah, go ahead and focus a little bit on there you go. See, so you can kind of see these, again, these are fairly normal looking gills. You all hopefully remember gills are kind of how fish breathe. And, they have a really, really fine structure, very thin layer so that the fish can get really, really small amounts of oxygen out of water because the oxygen levels in water are pretty low compared to air. So that's a little bit on that. The other thing I wanted to kind of talk to you about, and these are just some pictures, if you can hold these up, Pam. So this is a koi. Let's see light here. Okay. Yeah, so this is a koi here. And this is sort of what it looks like when we're opening them up and necrossing them. There's a piece of gill here, sorry, up there. And what we'll do is we'll actually do a really clean, what we call aseptic technique to get cultures of various tissues like the brain and kidney. A lot of times if we have a disease problem, we'll look for bacterial infections. And so we'll take a piece of that, use one of these called a loop, really small, that we'll touch the sample with, and then we'll plate them. If you want to grab the plate onto these plates, and you can kind of see, hopefully maybe hold it in the light a little bit. Actually, here, let me do this. So you can kind of see there's things growing on this, basically it's an agar plate, and those little kind of clumps are bacteria. This plate's a couple days old, so there's going to be little clumps there. What we'll do is we'll identify that bacteria if we get any, and we'll also do sensitivities. So I don't know if you can see, some of these have more of a clear area than others. See if you can, so you see how there's kind of a clear area, clear ring around one of them. And this one, it's a little more obvious. So we've got areas that are clear, areas around some of these, like this one, that doesn't have a very good clear area compared to this one. If you guys can see a little bit more white around that one versus this one. So that we'll measure that ring, and then we'll figure out whether or not that antibiotic can be used by the farmer. So that's kind of some of the things we do. Also wanted to show you, we do a lot of water quality testing. So this is basically our water quality test kit, and we will do various samples of water, including things like pH, ammonia, and nitrite. Those are really critical for the health of the fish. You know, we do a lot of other tests as well, but these are some of the basics. This is a dissolved oxygen meter here. Let's see, I can hold it up. Right here, this is our dissolved oxygen meter, which we'll use to measure levels of oxygen in the water. Again, really, really important. And so quite a bit of things we do. So a little bit, and again, sorry, I was trying to figure out how to turn my camera around on this, but I couldn't quite figure it out. Let me see. Nope. Okay, hang on one sec. I think she just,
There you go.
oh, there it is, okay.
You have to start.
All right, sorry, one sec. Okay, there. Thanks. Okay, she figured it out. So this is just our inside of our lab. We've got, again, a couple labs here, and then I'm going to walk you guys around outside as well. So this is just our inside lab. We've got, again, our scopes here. We've got a lot of, obviously, things like test tubes, et cetera. We've got screens because we do a lot of teaching to show both the students and the farmers what we're kind of dealing with. Lots of different types of parasites that we may see on the fish. We've got guides available online as well. Again, this is the water quality test kit, a little bit better view of that, and the culture plates I was talking about earlier. So I'm going to walk you guys around outside right now. So yeah, if you want to grab my phone too, just in case.
Roy, would this be a good time to ask some questions?
Yeah, sure, go for it.
All right. So when you take samples of the gills and fins, does that affect the fish's ability to breathe or swim?
No, not at all. And well, I should say it depends on obviously what the fish's problems were, but normally we're doing, if we're going to do it as a survival procedure. Sorry, we've got the generator on. I'm going next door. Normally,
Thanks for your patience, everyone. I'm sure Roy will be right back with us as soon as his signal returns.
okay, sorry about that. So this is our, again, we've got a lot of different racks of aquaria that we use. This system over here is actually a system that's designed for our non-native species group. Individual tanks that we can test different temperatures on. One of the big questions when we have a non-native or invasive fish is what kind of temperatures can they tolerate on the cold end, because Florida does get cold. And so this is where we do a lot of that testing. A lot of the farms, as well as a lot of our, in our facility, use burial vaults, which are actually where they put caskets in, but we use them for fish. So we actually hold fish in a lot of these, and we use a lot of these fish for different research projects as well. So I'm going to walk you through. One of our cool rooms here is our algal and kind of zooplankton room. So many of you may not be aware, but our lab here, the researchers here were the very first to breed dory, the Pacific blue tang, like in Finding Dory. So a lot of the really tricky marine larvae are very small and need very small food. So these are some of the food items that we grow. They're called copepods. If you can open the door, and in order to grow them, we need a lot of algae. So I'm going to take you guys into our algae room, which is a pretty cool room. You can open that door. Thanks. So this is actually our algae room. And this is Sarah here, who does a lot of, she's actually a master's student, but she's also doing a lot of work in the algae room and with the live feeds. So she says hi. So it's kind of cool. I don't know if you guys can see, but we have all these actually plastic bags, which are positively pressurized. So that's kind of why they look like they're ballooning out. That's to try to minimize contamination of these different types of algae. So we've got different algae that are raised here for food for the copepods, but we also use them as kind of to put in the water with the marine larvae, with the really, really young marine fish, to act as kind of like a background. So when they're feeding on some of the copepods I showed you earlier, they have like a better kind of depth perception. So we have a lot of different types of algae that we're raising here. And Sarah and some of the other folks are doing a lot of research, both with algae as well as copepods. So yeah, I always think this is kind of a cool room. So let's see. Yeah, if you want to grab that. So I may switch over to the phone and actually no, let's see how the Wi-Fi is. I'm gonna take you guys outside and I may have to switch over to my phone. We've got about 5 to 7 acres of ponds. We do a lot of work and research in our ponds as well. So this is the kind of the farm side. You guys.
While we wait for Roy to come back, if anybody has any questions for him, feel free to throw those in the chat. I'm seeing a lot of really great questions already, but if you want to throw those in, we could make the time to make sure those are answered for you. So any thoughts came up so far? Classroom connections, learning standard ideas, anything that you think you may want to ask Roy, feel free to throw it in that chat there.
I also have to interject and just say, I love seeing that family members are sneaking into the screen to watch what's happening. That's so cool.
They may want to stay for our next speaker as well.
So while we are waiting, this brings up a good point. When we traditionally do these PDs at the UF campus, you'll get to experience a lot of things in person. Can you hear me now? Hey, Roy, we sure can.
Okay, sorry. Yeah, so my Service Pro cut out. So these are the farm ponds we have here. So again, a lot of these we do research in. So if we're doing like nutrition studies, ponds are so varied. In Florida, a lot of the pond production is essentially earthen ponds. And in Central Florida, a lot of parts of Florida, we have a really high water table. So when we dig into the earth, basically the water table kind of fills the pond up. And so that's one of the reasons that aquarium fish production started here in Florida. So behind me are, again, our research ponds. Because the ponds can vary quite a bit, when we're doing different studies, we actually have to have a fairly high number of replicates, meaning that we have to repeat the same type of study in at least ideally like 4 to 6 ponds for each different thing that we're going to change, each different variable. Just because, you know, from one pond to another, there can be a lot of differences, even if they're right next to each other. So again, this is another view of the rest of the farm. And we're going to walk a little bit over to some of the buildings just to kind of show you what's going on. Some of you may be familiar. I'm going to point that out here. Let's see, if you see that big ball in the background, that's actually the Doppler radar. We're right next to the Ruskin National Weather Service. So it's kind of good if we have any hurricane questions, we can run over there and ask those guys. So I'm walking toward a couple of our greenhouses here. We've got 5 main greenhouses in addition to the hatchery. And let's see if you can see them, hopefully, behind me. And the one I kind of wanted to take you into is our marine our marine aquarium fish hatchery. So I'm gonna walk us over there. So again, you can see all the ponds as we're walking by. And again, all of our greenhouses here that have different aquarium systems, different projects going on. And as I was going to mention, if any of you are ever interested, just kind of let me know, and we can definitely kind of give you a little closer view if you're ever in the area and want to kind of visit. So I'm walking into our 5th greenhouse here, which is our kind of our rising tide room where we do a lot of our marine aquarium fish work. How's it going? So this is kind of what the inside of our greenhouse 5 looks like. We've got these big kind of circular vats here, which we house a lot of our fruit stock. As I mentioned, we do a lot of marine fish breeding here. And we also have some of these burial vaults that we house some of our fish. So this is one of the fish you guys can see. Hopefully, see if I can show them. Yeah, they're kind of hiding. Let's see. See if these guys are show. Let's see. Trying to see if you guys can see them. Let's see. Yeah, can you hopefully see that there's some fish in there?
Yeah, the colors are beautiful.
Yeah, those are Pacific blue tangs, and they're being a little bit tricky. We've got, let's see. There's some more. Yeah, see these guys. Yeah, hopefully you can see them a little bit, kind of coming in and out. So these are Pacific blue tangs. These are actually some of the dory fish that are our first generation. We spawned them probably a couple of years ago. Maybe it's been 2 years. They may be about 2 years old or so. I'm going to take us up into kind of the vat side, so you can see all these vats that we have for housing the breeder fish that we're using. I'm not sure if these guys are easier to see. Let's see. Hopefully you can see kind of behind me, or actually there in the middle, some of the blue tanks. So these are pretty large vats. We have different numbers of males and females. They're pretty cool. What they do is they typically spawn at dusk. So when the sun starts going down, these lay a floating egg because they have a little bit of oil droplets in the egg. We've got a sort of a pipe that will kind of collect the eggs as the water kind of makes a circular motion. There's a pipe that's got kind of a sort of cut halfway so that it'll catch it. Buckets here, where I don't know if you can see way in the distance there, we've got buckets that have strainers on them, and essentially the eggs are going to get put into those buckets, moved into another room where we raise our larvae. So again, this is just one of the different things that we do. Our main focuses here at the lab include obviously aquatic animal health, which is my area of focus. And I do work like with vaccines. Believe it or not, fish can be vaccinated. So we work with a number of our colleagues to develop vaccines for different diseases that the fish are getting to try to prevent the disease. I do a lot of work with like drug studies. We do a lot of discovery of kind of new different diseases because we work with so many different species. Another group, as I mentioned, does non-native and invasive species research. We've got a group that does reproduction, general production, and also fish ecology. So we have a group here that does work on maybe some of the game fish and seeing how they're doing in some areas around, around the state. So I couldn't see, was there a question? I can't see the question on my phone, sorry.
Yeah, Roy, is now a good time for questions?
Yeah, definitely.
Okay, I would love to just sit here and talk, hear you talk about fish all day. I am absolutely loving this, but we do have quite a bit of questions. One of them is, do you usually find microplastics in the fish?
Let me go outside. The fans are really loud. 1 second.
Sure.
Okay, could you repeat that question, please?
Absolutely. Do you usually find microplastics in the fish?
Good question. So we don't actually look for microplastics, at least when we're doing our normal necropsies, et cetera, we don't see anything obvious, but obviously since when we do use a microscope. So if they're going to be below the size that we would see with a regular light microscope, we wouldn't be necessarily picking them up. Anything that we could potentially see with 400X, with the high dry or even oil immersion, we're usually not seeing them. So again, because they are really, really small, it's not to say that we aren't, that they don't have it, but we just haven't really seen it as sort of in the way that we're looking at the fish.
Can you specify the difference between non-native and invasive?
Yeah, that's a really great question. A lot of folks use the term interchangeably, and UF actually has a whole group that is looking at defining the terms, as well as that looks at different species of non-native and invasive. So non-native just means that they're not from that area. They're not native to that area, so they were introduced. Now, invasive has a really kind of more complicated definition. And when we talk about invasive, usually we're talking about either like public health or economic or environmental or other type of impacts that are considered, significant. So we may have fish that are non-native but really don't have much impact. We may have fish that are maybe locally invasive, so maybe they're invasive but really under certain conditions. A good example, for example, would be when I'm not a plant person, but I think like water hyacinth and some of these or some of these other non-native plants, if you were into like aquatic birds like ducks, they actually provide a lot of habitat and even for some fish. But if you're like a landowner or a pond owner and they're kind of choking out your area, then they're considered like really a nuisance. So it's really a nuanced term, and it's really a lot less black and white than I think a lot of people will say. So for example, as I mentioned, some of the kind of non-native plants have actually provided a lot more habitat for some of the migratory birds. So again, it's really complicated. Another, not really an example, but sort of an example of how good and bad are gray is our the Big Bend power plant. Obviously people don't want, they want to reduce coal and all that sort of thing. But because of the warm water effluent, Big Bend power plant became a huge refuge for manatees. And I know they're kind of changing it out, and I think they're still trying to figure out, or they have some way of mitigating and keeping that water warm. But it was really the coal-powered sort of fuel that was allowing the manatees to stay in that area in the winter. So very, very complicated issues.
Thank you. We have time for a few more questions. Our next one is, what fish would you say is safe to eat from Florida?
I would say in general, there's a lot of really good guidance from, I think, FWC and some of the other agencies. I think, even some of the, and they're going to be for freshwater, there are going to be some areas where they may have higher content for certain heavy metals, et cetera. I think in general, typically in moderation, there aren't going to be major issues, but I would say a lot of that is probably going to be more local, and you have to sort of be aware. I personally am not too worried if I'm not gorging on like fish, every day from like a certain area. I would say a lot of the game fish are probably fairly safe. Again, that's going to depend. Obviously, if we're in a big red tide area, they may be dead anyway. So you've got to kind of be aware of sort of local guidelines with that, because it does vary kind of around the state.
Sure. How do you vaccinate fish? What is that process like?
Yeah, that's a great question. There's ways. The really more obvious way everyone's familiar with is by injection. And for our broodstock fish, some of the fish that we actually will inject anyway to hormonally reproduce them, that was kind of the first ones we ever vaccinated. Was we used a needle for these kind of bigger fish that could take a needle. And I've done vaccines also like in the Dominican Republic with smaller like pompano, and I've also done it, with larger fish here in Florida. We've also done immersion vaccines where, because a lot of the disease organisms or bacteria will come in the fish via the gills or maybe skin or even in the gut. If you think about it, the gut's kind of open. We'll put the vaccine in the water and then immerse the fish for a couple minutes so that all of the vaccine can kind of get in and around the fish and start entering that way. And then the third way we've done it is in medicated feed. So we'll take food, mix in the vaccine, and then feed it to them, and then it'll get into them through their gut. So those are kind of the three main ways we do it. Typically, immersion, putting it in the water and keeping the fish in for a couple minutes, is probably one of the easiest. But mixing it in the feed, if that works, because feed is a little bit more complicated dosing wise, and also whether it can get in the fish is also a really good alternative. We prefer those two methods, maybe feed even being a little bit easier if we can do it that way.
All right, let's see, maybe time for one or two more questions. Our next one is, why did you choose these specific types of fish for your research?
We have, obviously we're IFAS, and we're the land grant university. University of Florida is a primary land grant in Florida. So our main focus is assisting agriculture in Florida. We have an advisory committee comprised of producers, industry people that will help to guide our research. And so a lot of the fish we're working with are fish that are requested or based on production, things that the producers kind of need help with. So in terms of reproduction, we have, them saying, we'd like to know how to reproduce these fish and not have to either import them or take them from the wild. So that's kind of one, way we look at that. In terms of diseases, through our diagnostic lab, a lot of times we'll see diseases that are popping up in different areas, and we'll know, well, this is something we probably need to look into a little bit more if there's a way to, mitigate or prevent it. So a lot of it, again, is really driven by production in Florida. Our aquatic lab, also health lab, does work with fish and wildlife. So we do a lot of this health certification for the game fish being released. We do work with corals and a little bit of a kind of a combination. We do a lot of work with food fish as well, but aquarium fish are one of the main industries in Florida that we work with.
Excellent, thanks, Roy. And we have time for just one more question. Like I said, I wish I could just stay here all day asking you these questions. We have so many.
Yeah, no problem. And hopefully in person next time.
Yeah, that's right. That's right. All right. So when we consider things like antibiotics in water, how safe is that for us?
Well, when we're talking about food fish, obviously, hopefully no one's eating ornamental fish or aquarium pet fish. Food fish, it's very safe in the US. US FDA, the Food and Drug Administration, have really, really strict guidance. And that's why it's been so hard to get drugs available for food animals in general, for aquarium or aquacultured species in the US. And that actually is an issue because a lot of other countries that we import fish from may not have a strict regulation. So I'm incredibly comfortable with the, all the studies that have been done looking at residues, looking at safety, in the US as well as Canada and some of the other more developed countries. Some of the other countries may not have as very good and stringent regulations. So again, that's kind of one of my soapboxes is that, people are against aquaculture, or some people are in the US, but if we don't, the demand will be brought in from imported other countries that may or may not have the same regulations or care about the environment that we do here in the US. So that's my mini soapbox for you.
Well, Roy, this has been amazing. Thank you so much for taking time out of your schedule, sharing your expertise, and this really fascinating presentation. I've never seen anything like that before.
No problem. If any of you have any questions, these guys have my email, reach out. And if you're ever in the area or any of you are local, feel free to give us a call or email and swing by.
Well, thank you again. We really appreciate it.
No problem. Take care, everybody.
At this point, I'm going to turn things over to our next presenter, and we are thrilled to have our next presenters with us. We have Brent, David, and Zoe here to talk to us about Florida Springs. Brent and David are the co-founders of the nonprofit Kings of the Springs, who educate, care for, and clean up springs. And Zoe is a scientist and springs expert with us on behalf of the Florida Springs Institute. So without further ado, Brent, I think I'm going to turn things right over to you to get us started.
Hey, can you hear me okay?
You sound great.
Okay, good. I am going to start off this presentation with a video. And this is, I think, a good strong way for us to start, because that's one of the big things that we do when it comes to education. We do a lot of media. So before we introduce ourselves individually, I'm going to do this. Let's see if I can make it happen easily. All right. There we go. Okay, can everyone hear me still? Great, great. So the reason why I showed you a video to start off is because it's a huge thing of what we do. Whoop, hold on. There we go. It's a big part of what we do, and you'll see that a little bit more throughout the presentation. But let me introduce you to us. I'm Brent. I'm the co-founder and president of Kings of the Springs, and I kind of the backbone of our media when it comes to production. Everything that you saw in that video was either filmed by me or David, someone on our board, or a volunteer. So that's all from Florida. That's what we do, and it's a big part of why I really enjoy Kings of the Springs because I love getting in the water, but I also really like media. It's a background of mine. I also have a background in informal environmental education in theme parks, aquariums. I used to be a gator handler who would do some wrestling, but I couldn't resist putting in the conservation message while I did that. So I really enjoy teaching. It's a huge proponent of Kings of the Springs. It's really one of the biggest portions of what we do. We believe that if you jump on the water and have a good time and get things clean, you're making a difference. But if you can get a whole bunch of people to join you by sharing exciting media with them, you're doing an even greater job. So that's a big portion of what we do. David, you want to jump in and introduce yourself?
Yeah, absolutely. So hi, everybody. My name is David Kobiela. I am the vice president and co-founder of Kings of the Springs. I have a background in education. I have I've had 3 years of experience teaching middle school students of 7th graders, and I've spent a lot of time with 6th graders all the way up through 8th graders when I was working in the public school system at Oakview Middle School. And I also worked with Brent and some of his environmental education aspects of his jobs. And I've just love the Springs 100%. And I just could not help myself. I had to get together with Brent. We've known each other for 10 years, and we just had a big message to send to the people in Florida. And when I was a public school teacher, I realized that a lot of the students in my classrooms had no idea that there were these amazing, like world-class places to go, like really very, very close by. So I can't wait to share with you folks the experience that I had doing Kings of the Springs and being a public school teacher at the same time, and how that impacted my students, and how to bring adventure into your classrooms. So that's what I'm excited about for this presentation.
Zoe, you want to jump in?
Sure. All right. So yeah, so David and Brent are these awesome guys who run Kings of the Springs, and they actually get people into the water to clean up these beautiful places. On my side of things, I actually work with a nonprofit called Florida Springs Institute, and we are an organization geared towards spring science and education. So basically taking science that already exists and putting it into a form that's digestible for the public, and then also engaging the public in science activities. So we have a citizen science program called Springs Watch, and then we also go out and do our own sampling and springs monitoring to kind of get a gauge on these systems. So I'm currently the lead scientist at the Institute, and I worked with Kings of the Springs, David and Brent, on some of their projects, on some of their videos, and whenever they need, we provide facts and springs information to kind of bring the hands-on and the science together. So yeah, that's what I do.
I want to add to that just a little bit of our kind of how we work together. It's not just educational stuff, although we, obviously share resources back and forth, and we enjoy hanging out together. We will actually follow some of their fish counts. So that's when we first started hanging out with FSI, is when I volunteered to do one of their fish counts, float down the Ichtucknee, and noticed there was a lot of trash, and I could not believe how distracting it was for me to try to count the fish. So we kind of worked a little partnership where every time they go down the river to count the fish, we follow along behind them and pick up all that trash. So kind of a double whammy. So we have a good partnership with FSI as well as some other organizations. Let me give you guys a rundown of what today is going to look like. Hold on, let me share my screen again. Maybe. Got it. All right. Is that working okay for everyone? Okay. So this is what we're actually going to dive in the deep end. So we're going to be that diver. We're going to go through a few things today. Springs 101, I'm going to cover that. It's going to be kind of the basics. I know a lot of people are either, born in Florida or you've lived here long enough to at least become a teacher. So I'm going to kind of dive into just the basics of what's going on with the springs. And then Zoe's going to dive in a little bit more, teach about the science. She's going to get kind of into the technical stuff. And then David, as you know, our previous teacher, he is going to talk a little bit about lesson planning and working in the classroom. So let's start off with Springs 101. There's a lot going on. Honestly, it's an extremely complicated system here in Florida. It's pretty impressive, but it's all about the aquifer. So Florida is millions of years old, but it's honestly a little bit it's a little bit younger than the rest of North America. As the continent kind of spread away from Pangea, it didn't really have much as far as Florida goes. It was just kind of a little lump there at the bottom. And as the ocean existed, it deposited a lot of things. I think, Zoe, can you jump in and tell me the name of what it's something carbonate?
Oh, the mineral? Calcium carbonate.
Calcium carbonate, there it is. So it's sea life that existed over millions of years. And as it's deposited, the pressure of the water kind of compacts it down, and eventually you get limestone. And Zoe's probably cringing right now as I just used the most ridiculous way to explain something that's super complicated. But the limestone is basically what all of Florida is on top of. We're essentially a giant sandbar. And as the years went on, millions and millions of years, the water rose, and then it dipped and it rose. So we have different layers. And that limestone is easily eroded by water pressure and by just general acids that exist when it rains or when surface water starts to move through it. Excuse me. So that's where we get this Swiss cheese, essentially. So we're on a giant platform of limestone that is easily eroded over thousands of millions of years, and moving through that is water.
All right. If you want to keep working on the program and stuff and wait till he comes, that's fine.
Sorry about that.
That's all good. So that's important to know that as the foundation of where we exist on in Florida is the foundation of our knowledge. It's a lot more complicated, and Zoe will probably jump into a little bit of it, but it's important to know that's how this whole system works. It's on water pressure and the limestone and the aquifer. And then fossils, that's on there because the entirety of limestone is essentially what once was organic matter. And there are tons of fossils that have been deposited dating back millions of years. Oh, and I had one to show you, but I forgot it. That's one of the things that we really love to do. We find tons of fossils. It's also important to know, I think David is going to touch on this, but there's a lot of things that you need to know if you're going to collect fossils. If it's invertebrate, it's fine. You don't need a permit. But if it is a vertebrate, you're going to need a permit. It's $5. You get it from the museum here in Gainesville. You can mail in and they'll send it to you. But there's a lot that goes on with fossils. And yeah, David's got, David, you want to say something so your camera pops up? And then put that a little bit closer for us.
What you're seeing here, let's see if I can get a good angle on this. These are all shark teeth that were collected in the limestone from Florida. So you can see several different species of shark that have shed their teeth here.
Awesome. So just give you a little taste of what we do. It's one of the things that we really love to do the most is find fossils. And this is an incredibly rich state as far as searching for fossils. I could talk about that all day long, so let me force myself to move on to the water cycle. This is also incredibly important to know. So the first on the left, the rain drops on the land. And now that you've probably read that, I've got a song stuck in your head. You're welcome. So the rain drops, it comes down. And it hits multiple different places, but a lot of the most important stuff is what it picks up along the way. So that water is possibly going to go right into the aquifer as it immediately starts to seep into the ground, into the aquifer, or into the limestone. But it also often will end up on a curated lawn. That lawn could have contaminants in it, and that washes right down into the road. And then something that most people are common seeing around their neighborhoods, or especially downtown, you'll see a lot of places for that water to go. It's going to hit the drains, and those drains do not get treated. in most places. So if you flush your toilet, it's going to be treated. It's going to eventually end up back into the water cycle after being cleaned. But the water that goes into the road, into those drains, is right into a stream or a ditch, which eventually ends up in a river. And that river, let me use Gainesville as an example, is going to go, let's say a drop of water hits downtown, picks up some oil from a car along with it, goes into the street drain, goes into Depot Park, where it kind of cycles through a little bit there, eventually goes into Sweetwater Creek, and then into Paynes Prairie. And Paynes Prairie is the last stop before the water that we've contaminated potentially goes right into the aquifer, and then we drink it. Most places in Florida, a lot of people have wells that is literally pumping water straight out of the aquifer. You know, it's clean to drink, but if we keep polluting it, eventually it won't be. So it's important to know that. Some major issues, I've already touched on some of them. Water pollution is huge, huge. And I talked about lawns for a big reason, because a major issue for contaminating our own water is when we fertilize our lawns. It is a huge collection of nitrogen. For plants, you'll see, like if you go to Depot Park, the plants thrive there because it's oversaturated with things that are good for them. But in reality, for the system as a whole, it's not good. And Zoe will touch on that a little bit more. We're polluting ourselves, essentially, the own water that we drink. Another big one is agriculture. Agriculture is obviously extremely important for us to have, but we need more strict regulation to make sure that we're not putting tons and tons of chemicals to grow our food so we can eat, but polluting our water at the same time. It's a huge issue here in Florida. And then physical pollution is also a major problem. That's what we love to do. So education is huge, but we pick up tons of trash, and it is so much fun. As you can see in this picture right here, that's an incredibly old sausage can. We found cans and bottles, some of them dating back into the 1930s. Some of the David's got a mask on right now. I can't remember how old that is, but he's got some old school stuff that it dates. It's been covered by a deposit of sand in the middle of the river, and there's plastics in that. There are things that will leak out of the trash, and that will eventually not just poison us, but it'll poison the fish and the animals, and it's unsightly to look at. And then overpumping is going to be another main issue. In Florida, there is very, very few regulations on water consumption. 90% of the water that we drink here in Florida comes out of the aquifer. If we're poisoning ourselves, like there's nowhere else to get that water. So it's a major issue, is overpumping. So we need to remember that we rely on that. We rely on the springs, we rely on the water coming out of the aquifer. Otherwise, we got nowhere to go. So overpumping is a major issue that we need to address in the future, hopefully with legislation. Talking about legislation, I'll get to that in a moment. 3 ways that we can solve these issues. The first one, educating. I put it on there first because obviously that's what we're doing right here. We're helping you guys educate the next generation. And we believe that's more important than anything. So honestly, if you look at most of the things that KOTS puts our resources towards, it's education. We love organizing cleanups. We love getting out there. But if we don't tell people what's going on, they don't know. I intended to ask, or to try to organize a a survey on Zoom, but I dropped the ball on that one. But honestly, how many of you know that this is the largest concentration of freshwater springs in the world? I mean, most people that I talk to that grew up in Florida have no idea. And they don't know that 90% of our water comes from the aquifer. They don't know that beef that you're eating potentially has set toxins in because it was agriculturally, not maintained properly. So there's just so many things in this system that you have to know. Otherwise, you don't have the resources to fix it. If you have no idea, it's a problem. So educating is a big deal. And then volunteering is obviously our bread and butter. If you look at the picture that's on here, you're going to see me and David in there. And then every single other person in that photo is a volunteer. And even us, our board is completely unpaid. Every single person that works for KOTS, every single piece of trash is pulled out on our own time. And I would love to say that we got millions of dollars coming in and we could have an insane amount of resources, but we don't. And we really need to get that education out there, get those exciting videos out there so that people will be excited to come join us and volunteer. That's really important, that people are getting these problems solved. And the only way to do it is to get volunteers. And then I talked about legislation and talked about the next generation that we're raising. Hopefully you teachers are working on that. It's voting. Once they hit 18, if they have that passion for the springs, if they understand the aquifer, how it works and what the issues are, they're going to vote to fix them. They're going to look at politicians and they're going to look for resources. They're going to send out questions saying, like, what's your stance in the aquifer and this, and this. You know, and if that the legislator comes back and says, I don't know, they're probably not the person to vote for. But we really truly believe that when it all comes down to it, no matter how hard we work, no matter how much trash we pull out of the aquifer, if people aren't voting for legislation, for legislators that are going to fix these issues, then we're not going to make any progress. It's as simple as that. All right, so that is kind of the Springs 101. I know that you're probably left with a lot of questions. We will be giving you resources eventually at the end, but David and Zoe are going to also jump in here and give you quite a bit more information. So Zoe, I would like to hand it off to you to dive into spring science.
Okay, well, we shall dive right in. Let me share my screen. All right. Okay. So yeah, Brent went over a lot of really awesome points with the Springs 101 as far as, you know, pollution goes, as far as the water cycle goes, and that big takeaway that like the majority of us here in Florida rely on the aquifer in some capacity for our drinking water in our daily life. But you might be asking yourselves, okay, so all of these problems are going on with pollution. We have over pumping. How do we see this in the springs in a quantifiable way? And so that's my job on the science side, and you know, the job of other scientists with state agencies as well, and universities and such. But there, as far as our organization goes, there's 3 ways that we try to quantify springs health, and that's water quality, water quantity, so how much water is coming out of a spring, and how much biodiversity exists in the spring. And biodiversity refers to how many different species are in a spring. This goes for fish, plants, birds, turtles, insects, things like that, and also how much of them are there. So you could have a ton of fish, but if they're only one species, that's not a good amount of biodiversity. So anyway, in this picture here, it's me and my coworker and another coworker, and we are putting water probes into this little spring off of the Santa Fe River. And what this does is we measure several parameters this way. We measure dissolved oxygen, we measure specific conductance, and we also measure the pH. And what that can tell us is if there's a very, very low dissolved oxygen, springs are naturally low in dissolved oxygen because that water has been underground for a long time. There's no plants underground to release oxygen, and there's no air for the for oxygen to diffuse into the water. And so usually it's pretty low, but as you measure throughout a spring run where there's a lot of plants, you know, it's interacting with the atmosphere, there should be a higher level of dissolved oxygen. And across the board for water quality, dissolved oxygen is a major indicator of how healthy your system is. So we measure that at all of our springs. Water quantity, I will go into in a moment. Specific conductance, that's how many dissolved ions are in the water. So we talked about calcium carbonate. That produces a lot of ions in our water, but also salts. So if you have a spring closer to the coast, it's a saltier spring more often than not. And then also it can indicate pollution. So if you have a really high level of dissolved ions, for example, there's a spring about a mile from a dairy operation, and I'll get into that in a minute, but that specific conductance is like, I think it's like 1,000, whereas usually a spring is around 300. So we'll move on here, maybe. Okay, so I'm going to talk really quickly. So Brent mentioned nutrients and pollution getting into the water. So not only does it wash into our water from the surface, but also whatever we put on the surface here in Florida, if we are in a region with a lot of springs or an unconfined aquifer, that means there's no clay layer or anything that stops surface pollutants from getting into our groundwater. Anything we put on the land surface, mainly nutrients from agriculture and pesticides and things like that, will end up in our aquifer. We can actually measure that by taking water samples and analyzing them in the lab. But this is a picture of Fanning Springs. This is along the Suwannee River, which is a very, very heavy region of agriculture. As you can see, there is a lot of algae going on. So we talk about red tides and things like that, but we can also have nutrient proliferation in our springs. So the higher the nutrient, the better conditions are for algae. but it's also a delicate balance between how much nutrient you have in the water and how much flow is coming out of your spring as well. So really quickly, our state established limit for nutrients in our springs is 0.35 milligrams per liter of nitrate. Nitrate is a common used ingredient in fertilizer. Sorry, there's a fly. And right now, Fanning Spring is between about 3 and 6 milligrams per liter. So it's, you know, about 700 times or 700% larger than it should be. And in comparison, our drinking water standard is 10. So that's kind of a discrepancy we like to point out between what's considered ecologically healthy, which is this 0.35, and what is considered drinking water healthy. Now, I wouldn't drink the water if it's approaching 10, just saying. But then I'm going to talk about really quickly spring flow. So this is our water quantity. So right here, I have 2 of my coworkers, and they have a probe in the water, and that measures how much flow, how much water is rushing past them. And they will do this along a tape measure stretched across the spring run, which is the stream running out of a spring. And it'll give them a total number of how much water is coming out. And in Florida, I have this graph over here from the Swanee River Water Management District. It shows how much of our water pumping is coming from different sources. So public supply is by and large the largest user of water. Followed by that is agriculture, and then you have things like domestic self-supplied, so that would be like our wells in the rural areas, and then you have commercial industrial mining, so phosphate mines we've heard about recently in the news. And then we also have landscaping, so that can be like golf courses and things like that. So all of this water usage in combination with fertilizer usage is impacting our springs. When a spring has too much nutrient and low enough flow, algae will grow, the plants will die, and it just kind of spirals into a ecological problem. Okay, and then I have this picture, and this kind of shows all of the biodiversity in our springs, and how do we measure that? So at the Institute, we will conduct fish counts at the different springs that we're studying. It depends on what project we're working on. But we will also do snail surveys to count how many snails are in the spring, and we will also look at vegetation cover. And vegetation cover is probably one of the most important things. We refer to that as submerged aquatic vegetation, or SAV. And this is not only an issue in springs, but it's an issue in other waterways as well. So we heard about the manatees passing, well, not passing away, they died earlier this year. So there is absolutely no SAV in Indian River Lagoon when there used to be a lot. And we see that causing an ecological problem. And this time it's for the manatees. In other cases, it's other organisms that depend on plants for habitat and food. But I think I'm getting away from myself a little bit, but this is basically how we conduct our spring science at the Institute. And then I think Brent has a little video of one of our fish counts along the Ichetucknee. And so that is a video from our Springs Watch group, which is our citizen science group. And what that does is get citizens who don't have a science background out into the springs to learn how we do our science and also practice it themselves. So we'll go ahead and show that video.
Hey everybody, Kingston Springs is going to be working with the Florida Springs Institute today to save the world. We're going to count fish for conservation.
All right. Was that it, Zoe? Sorry,
I think
didn't cut
so.
you off.
Yeah, I was just gonna say, so yeah, that shows kind of how the science is done in that capacity, but go ahead and take it away, Brent.
Awesome. I believe David is up next. Let me, hold on, pull my presentation up.
And Zoe, there are a bunch of questions in the chat if you want to start to answer some of those while David's presenting.
Okay, so I'm going to go ahead and get started, and Brent's going to handle moving things along for me. So let's talk about bringing the springs into your classrooms, how to make the Florida Springs ecosystem exciting and engaging. Well, it kind of speaks for itself. Now, strangely, the first thing that we're going to talk about is ISS. So Brent, let's talk about in-school snorkeling. So food webs, first of all, like this is one of my students right here. I just want to let you guys get a little viewpoint of what it's like for these kids. A lot of them have never seen a pair of long fins before, or a snorkel, or a mask. I brought my gear in as a kind of exciting thing. When I put the wetsuit on him, and we talked about insulation and keeping core temperatures down, and we talked about animals that do that, like beluga whales and things like that. Tying what we use this gear for into how animals get it done out there in the real world. So I know the ISS joke was a little poke. I wanted to make my students feel like they were actually snorkeling while we were in class together. So we turned the lights down, and we put covered the windows, and everyone imagined that they had a snorkel on and all that. My point being that I urge everybody who's listening here to go out and experience the springs, actually have a real adventure for yourself, get inspired, take that energy that you get from the inspiration of being out there in the natural world, bring it back into the classroom. Because a lot of these kids are not having these adventures or accessing these public spaces that we're so lucky to have. So I wanted to try and bring that in. Now, I played a video, or I'm going to play a video in a minute, that's going to help understand how we're going to be experiencing all these following topics. Now, I wanted to relate everything to the Florida standards. And as I was only a 7th grade teacher, I taught life science for my first 2 years in sort of a mix. But these are some of the standards that I taught that I found it very easy to relate the Florida Springs to. Food webs, food chains, and food pyramids were all things that we talked about in life science. A lot of the trophic levels, where does the energy come from the sun, getting into that subaquatic vegetation, and then which animals feed on that subaquatic vegetation to, step up the food chain. I asked the students, what do you guys think? You're all Floridians. What do you think are the main predators in the springs? What can you guess would be the top predators out there? Eventually you lead up to alligators being the apex predators in the springs. Ecology, I would ask them to draw out what they, if they know anything about which animals that they've seen while they've been out. You usually get like 3 or 4 kids in your classroom that actually do go on these adventures, and they know all of the fish and they know all of the things, and they're great leaders at this moment. You give them a chance to shine and talk about some of their experiences with their family out in the water. You can bring it back to traits of organism. What makes, like for younger grade levels, what makes a manatee a mammal, not a fish? What makes a long-nosed gar a fish? You can talk about this, the plants, the different types of plants that are in the springs. And then going back up into 7th grade, where I kind of hung out, dichotomous keys and taxonomy. You're talking about animals and plants here. So this is a great way to tie in some local creatures into what you're doing to make it more real for the kids, and to make it seem that they can utilize the stuff that they're learning in the classroom, so that when they do go out to the springs, they can be the expert for their parents or for their friends, and give them that power of knowledge that they can use out there. So what we're going to do is, I've got Tessa here in the house saying Springsfield Guide, Springsfield Guide. We are going to give you a resource that's going to allow you to, it's actually been made by the Florida Springs Institute. I'm going to give you a link at the end of this presentation to access the Springs Field Guide, to have a guide for you. It's not just a paper guide, it's also a video guide. It shows you how to differentiate between different types of fish, different types of animals and plants that live in the springs. And it'll be an awesome classroom tool to kind of school your kids up on Florida Springs. So thank you, Tessa. She's on her way to work. So also, let's go ahead and jump in. Let me show you one of the videos that I used to virtually snorkel with my students. So we are using our footage to try and simulate some of the things that kids would see if they were to go snorkeling in the spring. So Brent, take it away. Thank you, Brent. So in that video, as you can see, you've got subaquatic vegetation, you've got birds, you've got mammals, you've got reptiles, you've got saltwater fish, you've got freshwater fish. There's so much to talk about. There's so much out there, and I get lit up just watching the videos. Sorry about the frame rate. I know for me it's a little bit choppy, but when you're playing it in the classroom from YouTube, you can upgrade it to 1080p and just blow your kids away with how beautiful everything is. And that gets me excited and as a teacher, that's awesome. If I can spend a day in my classroom excited, yes, that's great. My kids will benefit from that too. So Brent, if you want to just pull up the presentation again, and we'll move on to the next part. So how do you integrate this into your lessons? Here's a photo of me teaching some of the kids at Oakview Middle School. So the first way that I utilize this with my age group, which is 12-year-olds, to 13-year-olds, was I would have them utilize their science journals, which are a big thing in science classrooms, to take observations. So I would say, okay, I'm going to play this video, and I want you to focus on the animals that you see in the video. And I would have them take observations about what they're seeing in complete sentences, writing all that down. And then I would stop the video at the end. I would say, all right, we're going to do it completely different this time. I would play the same video back to them and tell them, this time you're going to focus on the plants. No animals. Don't give me anything about the animals. I want you to say as much as you can about the plants in this video, and then we're going to talk about them. I utilize dichotomous key worksheets, basically saying, how do you tell the difference between a gar or a bass? And where the fin positions are as dichotomous keys work. If you're not sure what dichotomous keys are, it's basically like 20 questions, but for animals. Yeah, there you go. Third graders using dichotomous keys. So it's like 20 questions, but you eventually settle on one species of animal, which blends really well into Linnaean taxonomy as well. There's the FSI Field ID Guide, which is an awesome tool if you know nothing about animals that live in the Florida Springs. That's okay, because you can pick like 5 of the creatures from our videos, you find them on the FSI Field Guide, use that to build a worksheet, bam, bam, bam. You're teaching kids how to differentiate different types of species out there using field observation, which leads really well into citizen science. You can teach these kids about these opportunities, because any of these kids with a parent over the age of 18, they can go on the fish count. Zoe, you may have to clarify that for me, but Kings of the Springs, we accept volunteers as long as they're with a parent. They can come with us. They can join us on this stuff. They can help us clean trash out of the rivers, and they find that really inspiring too. So taking data for science, teaching them how to count fish. You can do a fish count in the classroom if your kids get good enough at identifying the different types of fish. How many mullet did you see in that video? How many sunfish did you see in that video? You can do a fish count in class. And then ecosystem research, you can pause the video at different points and say, okay, you know, how do you think this fish depends on those plants, depends on that sun? Mary, yeah, I'm seeing some great questions. We'll come around, we'll circle around to that. So let's go ahead and go to our next slide, Brent. Human impacts was another standard that we talked a lot about in my science classes. Now, human impacts on the environment, not many of them are good, but there are some out there that are good. So you can go both ways with this. You can make this positive. If you want to make it positive in your classroom, you can play one of our cleanup videos, show them all this trash that comes out of the river, and then come around and say, you know what we're going to do? We're going to go clean up our campus, and we're going to do a cleanup right here in our school. So you give kids gloves, you give kids trash bags, and you go do some, we would just lead the kids around the school and pick up all types of stuff to make it look really nice and get all that stuff up off the ground. So we are going to play for you a video about a cleanup. Brent, do we have time for that?
Yeah, we can make it happen.
Let's do it. Let's show them what a cleanup actually looks like.
All right. Cell phone that we pulled out there, our keys. That's one of my students actually, the guy dancing. Here's our little pile of trash. I see a lot of people reaching out to us, or like planning on reaching out to us on social media. And I do have a couple things to say about river cleanups. When you're in a river, we do, a lot of times we'll create like a small sign-up sheet for people, because we can't pack like 75 to 100 people into a river and expect it to go perfectly. So a lot of times our teams are pretty small. But our overland teams, we also do land cleanups too. Those cleanups are going to be a lot more open access, and tons and tons of people will be able to sign up for those walking cleanups that we do as well. So Brent, why don't you go ahead and pull back up that slide that I was on, and I'm going to talk a little bit about fossils and how we can get into some of the education standards on that. So I brought a fossil out here to show you guys. This is something that you could find here. Doubtful you'd find it in the spring, but this is the type of thing that's stuck underground out here. This is a megalodon tooth. Kids love megalodons. My God. So just besides the Discovery Channel trying to do us all a favor and do a fake documentary proving that they are real, or they exist now, that was really confusing for my kids. But megalodons are extinct.
but they were a 40 to 50 foot long predatory shark that shed teeth all over Florida, so you can find them all over the place. I talk about how this is not bone, this is stone. I talk about mineralization, how the same process that creates stalactites and stalagmites also makes hard parts of animals like this turn into stone. I talk about how long that takes, the process of mineralization, and how it takes, over 12,000 years for it to happen. I talk about carbon dating. That's part of our standards as well in the science classrooms to do that. And I talk about the responsible collection of these fossils. This is an invertebrate. This is an invertebrate animal. Yeah, actually, I see a question there. Did you lend out any of the teeth? I was finding so many shark teeth that I would give them to my students at the end of the semester if they did well in my class. So I was using them. I gave them out for Halloween instead of candy. There's that many out there. So, this is a great way for me to, again, bring the adventure that I'm having outside of the classroom into the classroom, bring passion in when you're dealing with the kids to make everything more exciting. So yeah, responsible collection. You may want to let your kids know that you do need a permit if you're going to be collecting anything that has a backbone. So deer, mammoth, yes, there's mammoth bones out there. That's a great way to talk about the Ice Age and the history of Florida too. If you are able to collect some mammoth ivory or a tooth, make sure that you have a permit from the University of Florida. It costs a grand total of $5 to get a permit. So it is not hard to do. But we do want to talk about the responsible collection of fossils because there's a lot of things that are legal versus illegal to collect. For example, Native American artifacts, not legal to collect unless it's on your own private property. So I don't run out there and I tell kids, hey, go start fossil hunting. What I do is I say it's okay to find shark teeth because they're invertebrates, but I really don't get into the rest of it unless I was dealing with an advanced group of kids, because it's just a kind of a rat's nest of laws. And another thing you really want to stay away from when you're fossil hunting is digging into the banks of the rivers, because that erodes the riverbank. And that's another great way to talk about ecology with your kids. Is why do we care if we erode the riverbank? So anyhow, that is the long and short of how I integrated these things into the classroom. What I'm going to do here is in the chat, I'm going to share with you a link that was put together by Tessa Skiles, who's my partner. And she has a long history of springs conservation due to her father, Wes Skiles, who was a great videographer for National Geographic. And what she did was she put together some of his work, because he had been working before he passed away on springs conservation for 20, 30 years. And he put together a documentary called Water's Journey. And it was actually part of the Florida standards. I'm not sure if it still is, but it was a 6th grade standard to watch this documentary. So thousands and thousands of kids watched it. But it also has it's a great documentary on the Florida Springs and the challenges facing the Florida Springs. But also it comes with all of its study guides and all of its supporting material, which is an awesome thing to have in the classroom. I believe that Tessa is working on digitizing the 30-minute classroom version, but you can find the study guide here in this Google Drive document that I just threw into the chat. So that is open for everybody. We also have a few other resources in there. I'll guide you through that folder. You'll see that there's an activity in there where you can build your own aquifer. So you can simulate Florida's aquifer. Florida Springs Education links, a group of links there of great resources for you. There's Quenching the Thirst of Florida's Yards, which is a document that kind of highlights, remember that residential use slice of the water usage pie chart? This will kind of tell you why people are using so much water on their yards. And then the next 3 links are for the Water's Journey documentary, which is available to watch on YouTube. If you just search Water's Journey, you can pull up, you can maybe split it up. If you want to do the non-classroom version, you can split it up over 2 days. It's an hour long. So those are some great resources that you can bring into the classroom that were done by folks who've been at this for a while. You know, me and Brent are still, 3 years in here. We're still kind of new to the scene, but those links that I gave you are from, groups and, minds who have been at it for, a few decades. So I'm seeing some cool questions in the chat, and we're about at the where we're going to do Q&A, right?
Yeah, let me show one short video. We'll do a Q&A. This video is kind of going to act like an outro for us. It's basically like it's a great example of why we do what we do and why we love to do what we do. So if you could listen closely to the words, David and I wrote this together.
Nature is a part of us. Every forest, every river, every spring. We long to dive into a world that isn't fiction. That world is right here in front of us. And we're on a mission to protect it, to build on what we're given, and leave it better than we found it. Some of our beautiful, pristine, inspiring places are disappearing. But we can change that. Whether it's with paddles, fins, or boots, we're calling you to breach the surface of this world and find what makes it beautiful, to preserve and to protect it. And it all begins with us.
So I wanted to use that to kind of say thank you for, thank you for listening, and that this is who we are. But we also understand very strongly that we could not do this without teachers. We could not get the next generation excited. We couldn't get them educated about what needs to be done without teachers. So we were so excited that we had the opportunity to come share with you today. We hope you enjoyed learning about everything that we're covering and the Springs. And more than anything, I would love to see some of you come out with us. We do Springs generally like north of Orlando. We'll do cleanups, but we're trying to expand in hopefully in the next 3 or 4 months to other sections of the state. But if you're in the Panhandle, you can head our way. A couple of hours, you should be able to meet us somewhere near North Central Florida. We can do a cleanup, and we would love to have you guys. Brian, can we do a Q&A and leave 2.5 minutes for one more video?
Absolutely, absolutely. So one question that just came in is, do you have any collection systems on the water that pick up floating trash besides humans?
No, I love that question because the Osprey initiative actually does that up in Atlanta, and they have been expanding. I'm following them on Facebook. Osprey Initiative. I'd recommend checking it out. It's something that we've looked into. It's a very sticky thing to do because I know that the companies that do it have a problem with maintaining it. They have a lot of money has to come in for them to pay people to continuously clean those things out, because it's a lot of trash depending on where you are, but not yet, I should say. Maybe one day.
Teachers are wondering, what is the best way for them to find the YouTube videos that were shared today, or any other resources?
Yeah, we're on, if you Google us, Kings of the Springs, we're easy to pop up on Facebook and Instagram, and then YouTube, it's just youtube.com/Kings of the Springs. And any video pretty much any video we've ever made is going to end up on YouTube. So, and you guys are very welcome to use them in any way you'd like. The reason why we share it on there is because it's for you to use it.
Looking through the chat, I think Zoe did an amazing job answering most of the questions. So I'm just looking for any of the other ones.
Jennifer said, what do we do with the trash? Yeah. So if it's really cool, like a neat bottle, I will keep it and try to date it. And I work at the College of Journalism and Communication, and every week I have a little sign on my desk, and it says, how old is it? On this week, featuring, and then an old Coors can, and I try to get people to date that. Sometimes we'll share it on Facebook, but if it's bottles and cans, we try to recycle it. Anything that's recyclable, we'll generally try to do that. And then a lot of the places that we clean up, they'll roll out the red carpet for us because they know what we're doing and they love what we're doing. So they'll have a dumpster ready for us, or they'll give us access to their trash cans, and we'll toss it. But if it's if it's recyclable, we'll try to take care of it that way.
How many
things to
different
add to that?
Oh yes, I'm sorry, David. Go right ahead.
Two things to add to that. So we also partner with Current Problems too, who is doing a database on trash. Current Problems is another nonprofit organization here in the area that does cleanups, and we love them. They love us. So we weigh their trash and send the data over to them. Also, another thing that you can do if you're on the river and you didn't plan on doing a cleanup that day, but you have arms full of bottles, is sometimes I'll just see a passing kayak and I'll just be like, hey, do you mind taking these to a trash can? And I'll just give them like 6 bottles. And it's a great way to make new friends. And, just a little word of advice for anybody who's out there on the river.
I just saw a question by Maria that I should have covered. She wants to know, she said, on the calendar, we don't have any cleanups listed for the summer. Because all of us work full-time jobs and we are all, unpaid and trying to do this in our free time, it's very hard for us to plan cleanups way in advance. Also weather, Florida, as we just experienced. So we generally will post them online a week or 2 in advance. And at the moment we don't have any planned because we just did one a couple weeks ago. So we will do more cleanups, but sadly the best way to find out is to just follow us on Instagram or YouTube, or sorry, on Facebook. On Facebook, there's a way to prefer that to make sure that all of our notifications pop up when we post something. That's the best way to find out if we're doing a cleanup. And I really wish I had a better way to alert people to it. But at the moment, until we can grow as an organization and have people like doing this full time, it's kind of tough for us to have an active calendar going forward into the future.
How many springs have you cleaned up to this point?
Ooh, I can tell you we've hit 5 parks. It's really tough to say because like our big organized ones, we generally do the same 2 or 3 places because like Itchituckney, we're not allowed to do it anymore because they changed their rules during COVID. But that was a huge area, lots of people. We do Rainbow a lot, same thing, tons of inner tubers. I think we've done 5 or 6 springs. And honestly, we'll do anything though. If you guys have, if you're willing to organize a cleanup, we're happy to post it and organize it for you. But we'll really do anything. We'll hit up a park in the middle of Gainesville. If it's got trash, it doesn't matter. We'll do a lot of different places. So we don't just do springs. But I'd say we probably done 5 or 6 springs.
So I think the obvious ways that we could support you guys are, sharing educational materials, teaching things like that. Obviously, if we ever go to a spring, pick up things as well. But what other things would you say that we could do to support or share with other Floridians or tourists, or what piece of advice or takeaways would you say would be key here?
David, you want to take that one?
Yeah, absolutely. I think that the main thing that we are trying to influence here is a cultural shift. We are trying to make stewards out of our people who are enjoying the springs. For this, I usually talk about the 2-way street. For a long time, the philosophy about going out into nature has been, pack it in, pack it out. You bring whatever you're going to bring to the spring, and then you pack it out and you take it out with you so that you don't leave anything behind. And for a while that has worked, but I think now it's time for us to reflect on, we are not taking nothing with us. We are taking memories, we are taking passion, we are taking excitement, we are taking mental health. When we go to these places, we're taking all that. We're taking pictures, we're taking videos. So maybe it's time for us to culturally shift to where we need to figure out how to give back to these places. And that's what inspired me to create Kings of the Springs with Brent in the first place. But I think that if we can use our videos to inspire people to cross that bridge, if you can inspire your kids in your classroom to cross that bridge and come to a place in their life where they realize that they are taking from the environment, even if it's just their happiness and their peace of mind, and give that responsibility over to everybody. We all need to take care of this place. I think that cultural shift is something that we are striving to do. And I think as educators, you stand at a pulpit that allows you to make that happen a lot faster.
Thank you, David. What an important message. Brent, I'm going to turn things back to you as sort of our 2-minute warning.
All right. Thank you, everyone, for listening, and the museum. Brian and Stephanie, thank you so much. We had a great time. We hope everyone learned. And yeah, if you want to support us, you can always donate, but more than anything for teachers, educate, let the people know. One of the biggest things I talked about is voting. I think is super important. So we're going to end this on a funny note. Before I do share this last video, I popped in Brent at kingsofthesprings.org, David at kingsofthesprings.org, and hold on. Z Hendrickson, there's Zoe on there at kingsofsprings.org. Sorry, at Florida Springs Institute.org. If you've got questions, please hit us up. We would be happy to answer them. Keep in mind for David and I, if it's a deep scientific question, do not ask us. That's Zoe. Yeah.
Really quickly, I forgot to mention this, but we have at Florida Springs Institute, if you're interested in it, teachers K through 5, we have Aquatic Adventures. It is basically a coloring book, but it goes through like all of the stages of the aquifer and how it relates to drinking water. And if you're interested in this, you can email me or Florida Springs Institute. I had to throw that in there. Okay.
Yeah, thank you for doing so. All right, thank you, everyone. And we're gonna end on a fun note.
Hey y'all, we are at the Springs, the coolest of the Florida things. It's nature at its best, and all you locals know you can't resist a dip into the water. You'll be swimming like an otter, cause you know that here in Florida, in the summer it gets so much hotter.
My name is David, and my passion is unswerving, but I'm here to talk about something a little bit unnerving. The aquifer is hurting, and the water that is squirting is declining in quality, and it's very disconcerting.
What? You really thought we were gonna write a rap about the springs and not talk conservation?
Then you don't know us.
These are complicated problems. There's no easy way to solve them, but with science we can fix it, and it's time that we get started.
But Brent and I aren't scientists. We don't do numbers very well, so here's our friend Zoe. Zoe, time for some show and tell.
Yo, 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 when you talk about the springs and you say you're the kings, well, you better cover these 3 things. Gravity is pulling down through the ground all the nitrogen and fertilizer we don't want to drink. And your water comes from somewhere, don't care, we throw away 2 billion gallons every day. Get to the truth, give people proof. And in November, we'll see you in the voting booth.
Think about the drops you drink, what comes out of your sink. We're coming at you with a plan, so let's take a righteous stand.
It's a very simple message, and we're trying to explain it. We got all our friends together in the hopes that you retain it.
There's one tiny thing you take away, one little thing to do. Remember water when you vote, it all comes down to you. Think about the drops you drink, what comes out of your sink. We're coming at you with a plan, so let's take a righteous stand.
I like that voice. Yeah, that sounds perfect.
Thank you, everyone.
That was pretty awesome. I don't know, that's a great note to leave on for lunch. Thank you all for coming to share what you do. I think everybody truly enjoyed it. I know we put your documents and links that you've given us into our folders for the teachers. You've got a lot of fans and you've inspired, so we appreciate that. Teachers, we're going to break for lunch and we're going to come back at 1 o'clock so that you can